As we continue in chapter 11, which talks about parametric equations, we're going to look in the second section on how calculus can apply to these parametric equations and parametric curves. And we're going to start by looking at the formula for finding the derivative. So if x and y are both defined as functions of t, to find dy dx, you're going to take dy dt over dx dt. So you're going to take the derivative of both y and x relative to t and then create a fraction out of them. To find the second derivative, and that's the second box that I have there, what you will do is you're going to find the derivative with respect to t of that first function, of that first derivative, okay? So it says dy prime over dt. So the y prime is the answer you get here for the first derivative. So you're going to take the derivative of that with respect to t over dx dt. And I'll show you how this works, and it might actually be easier to see how it works with a couple examples, and that's what I'm going to do. I've got two examples here, and they both have the exact same instructions. It says, find an equation for the line tangent to the curve at the point defined by the given value of t. Also find the second derivative at this point. So the first equations that we're given here is x equals 2 cosine t, y equals 2 sine t, and the value of t that we're looking at is pi over 4. So we want to find the tangent line to this curve at pi equals 4. So to find the equation of the tangent line, we're going to need to find the slope at that point, and we're going to need to find the x and y values at t equals pi over 4. So I'm going to start with the slope. To find the slope, we're going to need to find the derivative of the curve at that point pi over 4. So to find the derivative, we're looking for dy dx. And according to definition, you're going to take the derivative of y with respect to t and put that over the derivative of x with respect to t. So if I come over here, y is 2 sine t. So if I take the derivative of y with respect to t, I'm going to get 2 cosine of t. And then I'm going to do the same thing here with the x. X is equal to 2 cosine t. The derivative of that is going to be negative 2 sine t. The 2's obviously will cancel. Cosine divided by sine is cotangent. So we have negative cotangent t. So that is our first derivative. So to find the equation of this tangent line, so I just abbreviated EQN for equation. We're going to first need to find the slope at t equals pi over 4, so I can use the derivative for that. So the slope is going to be negative cotangent of pi over 4. Well, cotangent of pi over 4 is 1, so we just get negative 1 for our slope. And then we need the x and y values here, and I'm going to call them x1, y1. So to find the value of the x coordinate, we're going to plug in pi over 4 into the x equation. So we have 2 times cosine of pi over 4. Cosine of pi over 4 is 1 over the square root of 2. So we have 2 times 1 over the square root of 2, or 2 over the square root of 2. and I'll work that out in just a second. For y, we're going to do the same thing. It's 2 times sine of pi over 4. Sine of pi over 4 is also 1 over the square root of 2. So once again, we have 2 over the square root of 2. And in both cases, 2 divided by the square root of 2 is just the square root of 2. So now we have our slope and we have a point. So to find the equation of the tangent line, we just go to our point slope form. So it's going to be y minus y1, so y minus the square root of 2, equals the slope, and then in parentheses, x minus x1, and their x1 is the square root of 2 as well. So we have y minus the square root of 2 is equal to negative x plus the square root of 2. I'm going to get y by itself, so adding the square root of 2 to both sides, we end up with y equals negative x plus 2 square roots of 2. So that's the equation of our tangent line. And with that, we're halfway done. The second half of the problem says to find the second derivative. So we want to find the second derivative here. So to find the second derivative, by definition, I'm going to take the derivative with respect to t of the first derivative, okay? So basically the dy dx is negative cotangent t. I'm going to take the derivative of that, and that goes in my numerator. The derivative of cotangent is cosecant squared, is negative cosecant squared. So the derivative of negative cotangent is just going to be a positive cosecant squared. Then in the denominator, I just put dx dt, which we already found is negative 2 sine t. Now, since cosecant is simply 1 over sine, this additional sign in the denominator is the same thing as just having another cosecant in the numerator. So I could rewrite this as negative 1/2 cosecant cubed t. And that's what I'm going to do. So we want to find the value of the second derivative at the point t equals pi over 4. So we have the formula for the second derivative. Now to find the value at pi over 4, we've got negative 1/2 cosecant cubed at pi over 4. Since the cosecant is just the reciprocal of sine, and since sine of pi over 4 is 1 over the square root of 2, we flip that around, cosecant of pi over 4 is just simply the square root of 2. So we have negative 1/2 times the square root of 2 cubed. So that's negative 1/2 times 2 square roots of 2 when you cube this out. So you end up with just negative square root of 2. And that is the second derivative at t equals pi over 4. So I'm going to go through the process one more time. Here we're given that x is 2t squared plus 3 and y equals t to the 4th. And we're going to find the equation of the tangent line and the second derivative at t equals negative 1. So in this case, I'm going to start out just like I did before. I'm going to find the first derivative. So dy dx. So that's going to be dy dt over dx dt. So y is t to the 4th, so dy dt is 4t cubed. Since x is 2t squared plus 3, dx dt is going to be 4t. So when we divide out, the formula here for the first derivative is just t squared. So to do the equation of our tangent line, the slope is going to be then -1 squared, so our slope is 1. And to get our point x1, y1, we're just taking -1 and plugging into the equations for both x and y. When t is -1, for x, -1 squared is going to be +1. So 2 times 1 is 2, plus 3 is 5. And the y value, -1 to the 4th, is just 1. So again, plugging into the point slope equation of a line, we have y minus 1 is equal to that slope 1 times x minus 5. So y minus 1 equals x minus 5. Add 1 to both sides, and we have y equals x minus 4. So we're halfway there. To finish this one up, we're going to find the second derivative. So again, to find the second derivative, we're going to take the derivative of the first derivative. So take the derivative of t squared, you get 2t. Put that over dx dt, which is 4t. And you end up with just 1/2. So the second derivative here is simply a constant. So at t equals -1, it's going to be 1/2. It doesn't change. In the next video, we're going to look at integrating with these parametric equations.